Mic check. Alright, what's going on everybody? Welcome back to the channel. I'm not dead. Surprise. I know it's been a minute, or maybe even 2. But I'm back. Now I have no video ideas right now, so please if you need a tutorial, let me know in the comments, and I will likely make a video on it. So today I'm going to be sharing with you my solution for custom destruction physics in Unity. And if you've been around, you'll notice a problem with most of the tutorials. Pretty much what they'll do is they'll take a mesh and then make a destroyed variant of it. Once you hit the object, they'll replace it with the destroyed variant on impact. This works for things that you want to shatter the whole object immediately, like maybe a glass bottle. But this doesn't necessarily work for larger objects like walls. However, there are solutions out there for more realistic shatter physics, but generally they cost $10 to $60 on the Unity asset store. I don't want to pay that kind of money for an asset that I'm going to use once or twice, so I decided, f it, I'll do it myself. So today I'll be showing you how I shatter meshes in Blender, and then also how I import them into Unity and set up the script. And as always, everything that I use in my videos is in the description, so if you want to check that out, go ahead and do that. But please watch the whole video. I need my watch time. Anyhow, let's get coding. Alright, so in Unity, I created a simple scene here using assets from Quixel Bridge. You can find all of these assets in the description down below, and I made a 60-second tutorial on how to download it. Now when I hit play, you see I can throw rocks at this wall. But currently it does nothing because obviously we haven't added any destruction physics to it. It's just a wall. Now to shatter, like most tutorials have, open up your wall in Blender or whatever your mesh is. And then you need to use the SmartFracture add-on and hit Edit, Preferences, Add-ons, and then search for SmartFracture. Make sure that you enable this. Now if you want to shatter your object, you first select it and then hit F3 and search for SmartFracture. And then here you can kind of mess around with everything, but the only two that I tend to use are source limit and noise. Noise is how randomized it is. 0 would make it so it's perfectly square chunks. And then if you add some noise to it, you can get some pretty interesting shapes. And then if you want to go a step further, you can even subdivide these meshes even more. And if I apply the textures to it, you'll see that it's perfectly identical. Now there is one small problem with this, and that is that you can see small cracks in the walls. This is just an issue with Blender, and I'm not sure why they have it like this, but there are tiny cracks in all the walls. The only method I found is before you decimate your mesh, you just have to scale it up. I scale it up by 100, and then you can apply your SmartFracture. Now the issue is that our mesh is now 100 times bigger, so now you just have to set the scale factor within the import settings to 0.01. And now it's the right size, and you can see that there are no noticeable cracks, yet it's still perfectly fractured. Now before we can fracture the solid wall, we have to set up the fractured wall. To do this, I just add a mesh collider and a rigid body to every cell. The wall kind of crumbles apart. Now to actually use the fractured wall, we need to make it a child of the wall at the same exact position, and then disable it. And we'll just enable the fractured wall whenever we want to destroy the mesh. Now to actually fracture it, I'm just going to use my fracture script. Fractured object is the wall fractured. And now when we hit play, you can break the wall. But the only difficulty about this is no matter what part of the mesh you hit, it will shatter the entire mesh. Now my script fixes this, but it's a little bit more complicated to set up. Now the primary difference between my solution and the basic solution is that mine only uses a fractured wall. So we can just take this out and then apply my script to it. SmartFracture. But there is a little bit more setup. We have to give every cell a SmartFracture script. Now you'll see that there's a parameter grounded. This is for all cells that are connected to something that would keep them upright. So since these three are the only ones that are connected to the ground, they are all grounded. If I break this lower cell, it makes the top half shatter. But how does this all work? All that my script does is it shows connections between each of the cells in the mesh and decides whether or not it should be disconnected or not from the rest of the mesh. You can see that these lines visualize which neighboring cells it's connected to. It's not perfect, but works well enough for a wall like this. And if you remove all connections from one mesh, you'll see that it's now isolated and you can move it. And it doesn't disrupt anything else. However, if I remove enough connections, you'll see that now there are 2 cells above this one, but they're still holding up. However, if I break the bottom one, it all crumbles. This is because it's able to trace back and tell whether or not it's connected in one way or another to a grounded part of the mesh. In Unity, we start with the SmartFracture script, which is applied to the parent of all of the cells. Now, there are only 2 variables: the break radius, which is the radius at which a collision will affect any cells. So if it's really big, it will affect a large number of cells, and if it's really small, it won't affect many. The break force is just how much force is required to actually break a cell and remove its connections. Now, all that the script does is, on startup, it will initialize all of the subfractures. This just stores in memory all of the children's cells so that we can figure out what to do with them. And then we have to set up all of the connections. So we loop through every cell, and then we use a box collider just to use Unity's auto-generated bounds for the mesh. And then we create an overlap box. So we're pretty much just figuring out which meshes are within a square box of the mesh. If we take this cell, for example, and add a box collider, you can see that all neighboring cells in one way or another are going to be within the bounds of the box collider. I thought this was a really interesting solution for this because you don't have to do any crazy math. You literally just use a box collider, steal the dimensions, and then use an overlap box to figure out whichever other cells it is colliding with. And then if it's colliding with another subfracture, so one of the other children, then it will add it to the list of connections. Now, for any given cell, we also have a script. First, we initialize a parent and set isCanMag to true for the rigid body. This just sets up physics so that it won't start broken. And by setting isCanMag to false later, that's how we add physics. So every frame we loop through all connections that a given cell has, and then we remove all non-grounded connections. This is just making sure that none of the connections are isolated, because we don't want any floaters like in Minecraft. Now I set this boolean to somehow grounded to false. This is pretty much just a test to see if in some way or another it's connected to one of these bottom grounded pieces. Because if it's not connected to these one way or another, then it's going to be floating, and we don't want that. Now, if it didn't manage to do that, then it will check one more. So take this one for example. None of its connections are grounded. So it will have to check each of these and see if one of their adjacent tiles are grounded. And this one, for example, it does have a grounded tile adjacent to it. So it's just pretty much able to iterate and eventually find a grounded connection. Now, if this isn't working for you, you can do like another for loop in here. I just wanted to keep it to 2 for the sake of the tutorial. And then finally we set connected to grounded in one way or another, and it has some form of connections to another tile, or it is self-grounded. And if it's not connected, then it will apply physics. Now, when it collides with anything, we need to determine whether or not it should become isolated. We need to decide whether or not it should fracture. And we do that by asking whether or not the collision impulse magnitude is greater than the break force. And if so, then it will remove all connections and set grounded to false. Now this will pretty much just make it so that it's no longer connected. Now that leads back to here. So it will loop through every cell when we fracture and make sure that the distance between the cell and the point of collision is greater than break radius. If this distance is true, it will set every cell within the distance to no longer be connected. And of course, if it is no longer connected, we add physics to it, which makes it shatter. This is what I find so interesting about this script, is we're able to have overhangs like this, and you're not able to have that with any other type of destruction script, let alone for free, so smash like. Alright, that'll do it for this year's video. If you like this video, make sure to smash like so more people can see it. And if you want to get recommended more videos like this, make sure to subscribe. And if you're having any issues, make sure to join my Discord, link in the description. And yeah, I'll see you in the next one.